This is M. Sambaraj, Assistant Professor, Institute of Aeronautical Engineering College. Today we are going to discuss about number system or properties of numbers. Subtopics in number system. First one, number of zeros. Second, unit digit. Third, remainder concept. Fourth, LCM and HCF. Fifth, logarithm. Total we have 5 subtopics in number system. Let's start number of zeros concept. Number of zeros means this topic belongs to simplification or properties of numbers. Here calculate only find the total number of end zeros by using multiplication operator. Suppose find the number of end zeros at the end of 97,000 is dash. 97,000 contains number of end zeros. Only 3 only correct. Similarly, find the number of end zeros at the end of 10,500 is dash. A total number of zeros 3, but calculate only end zeros. Total number of zeros that cannot be possible by using general calculation, but end zeros only possible by using product operator. Here suppose 10 is multiplied by any number, we get end zero, otherwise zeros not possible. Now by using product calculate only end zeros, that is called number of zeros concept. Here concentrate only end zeros. Okay, right. Suppose first example number 1. Find the number of zeros at the end of the product of 1 to the power of 10, 2 to the power of 20, 7 to the power of 30, 5 to the power of 25, 3 to the power of 30, 8 to 9 to the power of 25. Okay? The general method. If you want to end 0, 10 is multiplied by any number, we get 0. Otherwise, 0 is not possible. If you want to 0, 10 means 10 multiples. 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, and so on. If 10 is multiplied by any number, then end 0 possible. Otherwise, end 0 not possible. That is the logic of the problem. By using above example, 10 not given. If 10 not given, consider only 10 multiples means 2 into 5. Again, 2 into 5. That means 10. If 10 not given, consider only 10 multiples. Other numbers are not possible. Those numbers are negligible. Above example, 1 to the power of 10 negligible, 7 to the power of 30 negligible, 3 to the power of 30 negligible, 9 to the power of 25 negligible. If you want to 0, consider only 2 and 5 combination only. Suppose 1 is multiplied by any number, 0 is not possible. 1 into 2, 0 not possible. 7 into 3, 21, 0 not possible. 3 into 3, 3 into 2, 3 into 5, 0 not possible. 9 into 1, 9 into 2, and so on. 9 into 9, 0 possible. But 9 into 10, the 10 is multiplied by any number, we get 0, but otherwise 0 not possible. In next year, consider only 2 to the power of 20 into 5 to the power of 25. Consider only 2 and 5 multiples only. Single 2 not possible 0. Single 5 not possible 0. 2 and 5 combination is compulsory. In next 5 to the power of 25 also written as a 5 to the power of 20. 5 to the power of 20 into 5 to the power of 5. 5 to the power of 20 into 5 to the power of 5. Single 5 not possible 0. If you want 0, 2 and 5 combination compulsory. A number of 2 is 20. Number of 5 is 20. A power m into b power n, ab power n, that is 10 to the power of 20. In general, 10 to the power of 1, we get 1 0. 10 to the power of 2, we get 2 zeros. 10 to the power of 3, 3 zeros. And so on, 10 to the power of n, n zeros. A 10 to the power of 20, it gives 20 zeros. Option B only correct. This problem meaning 10 to the power of 20 into 1 to the power of 10 into 5 to the power of 25 into 7 to the power of 30 into 9 to the power of 25. The 10 to the power of 20 into next numbers, and 10 to the power of 20 is multiplied by any number, we get 20 zeros. Then answer is option B only correct. This is about concept of the topic. Once again, here procedure. Here step number 1, procedure. Step number 1, above problem convert into a multiples of 2 and multiples of 5. Multiples of 2 and multiples of 5. Other numbers are negligible. 1, 3, 7, 9 negligible. Next, second step, count total number of 2's and total number of 5's. Next, step number 3, number of zeros is equal to lowest power of 2 and 5. Comparing powers of 2 and 5, which is the lowest power, that is your answer. This is called a shortcut method. Number of zeros, the type of questions are given. Just you apply short procedure. That procedure, first statement, complete problem, convert into a multiples of 2 and multiples of 5. Except 2 multiples and 5 multiples, remaining all are negligible. Suppose above example, consider only 2 and 5, other numbers are negligible. 1, 7, 3, 9 negligible. Consider only 2 and 5. Second step, count number of 2's and number of 5's. Number of 2's 20, number of 5's 25. Therefore, number of zeros means lowest power of 2 and 5. Which is the lowest power? That is your answer. Here 20, 25, lowest power only 20. Then answer 20 zeros only possible. Option B only correct. This is called a shortcut method. Okay. Yes, I covered both general method and the shortcut method. Okay. Then you apply only short method. Remaining questions in number of zeros concept. A second example, same method. Apply short method. Step number 1. Complete problem, convert into a multiples of 2 and multiples of 2 and multiples of 5. Other numbers are negligible. Consider 2 multiples and 5 multiples. 2 multiples 2, 4, 6, 8, 10, 12, 14 and so on. These are considered. And 5 multiples 5, 10, 15, 20 and so on. Other numbers only negligible. Here 1, 7, 3, 9 negligible. Next, count total number of 2's. A total number of 2 means 14. 14 is called 2 into 7. And 35 is called 5 into 7. 14 all to the power of 20 means 2 to the power of 20, 7 to the power of 20. But 7 to the power of 20 negligible. 35 all to the power of 20, 14 all to the power of 30, 2 to the power of 30 into 7 to the power of 30. 7 to the power of 30 negligible. Next, 35 all to the power of 20. 35 means 5 into 7, 5 to the power of 20 into 7 to the power of 20. 7 to the power of 20 negligible. Next, count total number of 2's. A total number of 2's 2 to the power of 10. Next, 2 to the power of 30. Next, number of 5's 5 to the power of 25. Next, 5 to the power of 20. 5 to the power of 20. The next, number of 2's 10 plus 30, 40. Number of 5's 25 plus 20, 45. Number of 2's 40. Number of 5's 45. Number of zeros, lowest power of 2 and 5. Here 40, 45, lowest power 40. Option C only correct. Option C only correct. Okay. Right. Next. Example number 3. Example number 3. Okay. A third example, important sequence model. A note sequence type of questions are given. Please note sequence method. Consider any continuous series or sequence method. Number of 2's is always more than number of 5's. For continuous series type of questions are given, no need to calculate number of 2's. Just to calculate only number of 5's. Number of 5's is nothing but number of zeros. You don't waste your time. Simple technique. Continuous series type of questions are given. Number of 2's is always more than number of 5's. But this concept exists only lowest power of 2 and 5. For continuous series problems, lowest power exists only 5. Lowest power exists only 5. Just to calculate only number of 5s. Just to calculate only number of 5s. Number of 5s means 1 to the power of 1 into 2 to the power of 2 into 3 to the power of 3 and so on 25 all to the power of 25. Here consider only 5 multiples. If 5 multiples means here 5 to the power of 5, it gives 5 zeros. Here 10 to the power of 10, it gives 10 zeros. Next 15 all to the power of 15, it gives 15 zeros. Here next 20 all to the power of 20, it gives 20 zeros. 25 all to the power of 25. Here calculate only number of 5s. 5 to the power of 2 all to the power of 25 is equal to 5 to the power of 50. This is important. Once more, easy, simple calculation. Here consider only 5 multiples because this problem belongs to series or sequence method. 5 multiples, 1 to 25, 5 multiples, 5, 10, 15, 20, 25. 5 to the power of 5, number of 5s, only 5. 10 to the power of 10, 5 into 2, number of 5s, only 10. 15 all to the power of 15, 5 into 3, number of 5s, only 15. 20 all to the power of 20, number of 5s, only 20. 25 all to the power of 25. Here calculate only this problem depending only number of 5s. 25 is also written as 5 to the power of 2 all to the power of 25. That means number of 5s 50. Therefore, total number of 5s 5 plus 10 plus 15 plus 20 plus 50 is equal to 100. Number of 5s is equal to 100. Number of zeros is equal to 100. Then, therefore, answer is option A. This is about number of zeros concept. Okay. Once again, here two methods only important. First method, if the problem belongs to not series, then you calculate total number of 2s and total number of 5s. But always consider only 2 multiples and 5 multiples. Other numbers are negligible. Other numbers are negligible. Next, if the problem belongs to series concept, then calculate only number of 5s. Don't consider number of 2s. Because number of zeros concept only for lowest power. That is possible only 5. Just calculate only number of 5. Suppose if you calculate number of 2s is more than 200. More than 100. Suppose assumption number of 2s in this problem. Suppose 2 to the power of 200. A 2 to the power of 200 into 5 to the power of 100. Lowest power only 100. Therefore, answer is option A only correct. Okay, this is about number of zeros concept, series method, not series method. Okay, right. Next, fourth example, by using factorial. Note, factorial, n factorial. N factorial means n into n minus 1 into n minus 2 into and so on 3 into 2 into 1. Example, 8 factorial. 8 into 7 into 5 into 6 into and so on 3 into 2 into 1 is called series. The factorial is also called series. For series problems, calculate only number of 5s. This problem consider only number of 5s. That is your answer. You don't need to calculate number of 2s because factorial is also called series concept. For series concept, lowest power exists only 5. Therefore, number of zeros is equal to number of 5s. They calculate only number of 5s. Here find the number of zeros at the end of 1000 factorial. They calculate number of 5s means divisible by 5. Here calculate number of 2s divisible by 2. Calculate number of 3s divisible by 3 and so on. But this problem just to calculate only number of 5s, therefore divisible by 5. By using LCM method, 5 into 200, remainder is equal to 0. Next 5 into 40, remainder is equal to 0. 5 into 8, remainder is 0. Next 5 into 1, remainder is 3. But consider only quotient but not remainder. Number of 5s is equal to 200 plus 40 plus 8 plus 1 is equal to 249. Option C only correct. A shortcut method, but general method, 1000 factorial means 1 into 2 into 3 into and so on 1000. In that equation, calculate total number of 5s. That method lengthy and complex method, 1 minute it's not sufficient. By using LCM property, very simple. Each case is divisible by 5. Consider only quotient but not remainder. Sum of the quotient is number of 5s. Number of 5s means number of zeros. That is 249. Option C only correct. Okay. Next, number 5. Same method. Here calculate total number of zeros at the end of 150 factorial. Say, if you want to end 0, calculate only number of ways by using series concept. Next method, 5 into 30, remainder is 0. Next 5 into 6, remainder is 0. Next 5 into 1, remainder is 1. Consider only sum of the quotient. Sum of the quotient 30 plus 6 plus 1 is 37. Again, option C only correct. This is shortcut method. General method also available. If you want to general procedure, just you calculate only number of ways by using 1 into 2 into 3 into up to 150. And up to 150 calculate only multiples of 5's. In multiples of 5's, consider only 5, that is called number of zeros. I think 1 to 150, that method lengthy and complex method, but using LCM property very simple. Okay. Next, sixth one. Here find the largest power of 30 that contained in 100 factorial. A largest power of 3 divisible by 3. Largest power of 7 divisible by 7. Largest power of 5 divisible by 5 and so on. But your question is largest power of 30. 30 convert into your prime factors. 30 convert into your prime factors 2 into 3 into 5, but not directly 30 is not correct. Sir, largest power of 30 that contained in 100 factorial. Here directly 100 by 30, 30 into 3, 90, remainder 3. 3 is not correct answer because 30 means multiples also available. Here 2 into 3 into 5, that multiples also available. Always composite number convert into a prime factors. Here 30 composite number convert into prime factors 2 into 3 into 5. Yet using prime factors, a number of 2's is more than 3. Number of 3's is more than 5. Lowest power exists only largest prime factor. Largest prime factor, that is 5. Therefore, 100 divisible by 5. Here method 5 into 20. Next 5 into 4. Sum of the quotient to 24. Option B only correct. Suppose similarly, largest power of 21. 21 convert into a prime factors 3 into 7. Divisible by 7. That is our answer. Once again, composite number, the type of questions are given, always convert into prime factors. Using prime factors, consider only largest prime factor, that is only divisible. That is our answer. But not no need to calculate number of 2's, number of 3's, number of 5's. That method is also correct. But we want a solution by using only largest prime factor, that is only divisible by above factorial. That is only correct answer of the given problem. Okay. Yes. Last example. Find the largest power of 143 that contained in 125 factorial. Similarly, say here 143 is not a prime number. If 143 prime number, option A, because up to 125 143 not available. So answer is option A. But 143 is not a prime number. If 143 composite number, convert into a prime factors means 11 into 13. The next 125 factorial divisible by 13, consider only largest prime number 13. The 125 divisible by 13, 13 into 9, 117, remainder is 5, but consider only quotient A, but not remainder, 9 only correct. Suppose largest power of 139 that contained in 125 factorial. In 125 factorial, 139 not given, not available, then answer is not possible. You check the problem. If the problem is belongs to prime number, then answer not possible. If the problem is composite number, that answer possible because 11 into 13 multiples also available. And consider only largest prime number 13. 125 divisible by 13. 13 into 9, 117. Remainder 8, but consider only quotient but not remainder. Answer is 9 only correct. Option B only correct. This is about number of zeros concept. Okay. Yes. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.